Hey everybody, it's Eric again, post-Christmas. I hope everybody had a good Christmas. We're moving into New Year's now. And I gotta go back to work tomorrow. Boo. But get another break for New Year's Eve. So, get a little bit of work done on the car today if I can. Excuse me, good grief. So we're still working on electrical stuff here. I'm not sure what I'm going to do today. There's a couple of things I was going to work on. I've got the cooling fans I can work on. I'm not sure I have everything I need for that. Continue wrapping up harness stuff, get things tucked away. I was also considering for the instrument cluster here, I've got the special harness for that, which I might do. I don't know, there's a bunch of little miscellaneous electrical type stuff. So I'm just going to get started here. I think I'll start by trying to tuck this thing up here, get this out of the way, so I've got to get that into the wire braid. The one complicating factor here is there's the harness that comes off of this for the windshield washer, and you know, little miscellaneous wires. What is this? Brake switch light. I don't have that, so I'll probably tuck that up inside the harness, but whatever. Just clean things up here. Here we go. This is what I was looking for. So windshield washer pump. They give you an extra long cable here because some of the Camaros have the pump way up here. Mine is back there, so this is too long. So in theory, I should cut this and redo this. We'll see. Anyway, let's get started with that. So anyway, the point of all that is I gotta snip all of the, I can't even think right now, what are these things called? Clamps, whatever, wire ties. I had to cut all these off to extract this thing back to this point, and I can just leave it like that and just kind of bundle this thing over on itself like this, or I can keep cutting it back so I can pull it back further. I'll probably just leave it like this. I don't think there's any reason to take it all out. Anyway, we'll see. Okay, so just like we showed in another video, to cap one of these wires off, I just take a piece of heat shrink tubing, stick that on the end there, and then I'll use the heat gun. Grab that real quick. Give that a blast. When that heats up, I pinch that off to close it. Where this has that adhesive in there, so that makes a watertight seal. At least in theory. That's the first of that heat shrink tubing I've used. Hopefully that is the kind with the goop in it. Yeah, it seems to be. If this will focus, that is. There you go. You can see the seal inside there. I don't know if you can see it around the back. It's hard to tell on this viewfinder. This camera's so old and dirty. Now you can make that a lot shorter. Obviously, it doesn't need to be that long, but I don't really care. It's going to be inside the wire loom. Okay, so we gotta track this kind of as far back to the fuse block as we can to feed this stuff on there. And then this is buried. And then we have the windshield washer pump wire. Gotta pull that off. So kind of figure out where that needs to go, and if I can just back it on itself all the way inside that wire and then get it to the right length, then that would be good. So I think that goes there. It doesn't really matter right now, but I'm gonna stick it there, and I folded it back on itself here. So you got a sense of where it needs to go. Then I'll just tuck this all inside the loom, the wire braid, and I'll leave it unbound in there so I can slide it in and out if necessary to get the right length. That should be pretty close. And, yeah, we'll get started with it. All right, I got that up in there. I don't know how well I'm going to be able to tape that off, but we'll try. Yeah, excuse me, had to sneeze. So I got this thing tucked up to here. So the first breakout is right here with the side marker lights and turn signal and stuff, headlight, so all this stuff here. So I will tape this off right here in both places to seal that. I'll see if I can get some other braid on here. I probably won't. I might just leave these loose like this. Then same thing here. We have the sorry, left turn signal, that was left side marker. Brakes out there, and then perfect length here. This is where the horns break off, and that's where I ran out of wire braid. So that's as far as I can go with that, because I don't have any more of this diameter stuff. This is the 1/2 inch, I think. So I have that little bit dangling left over there that I'll have to deal with later. But I'm going to take this, get that stuff taped off that I talked about, and then get it tucked up underneath the fender there, and get it out of the way, hopefully. All right, got all of this stuff bound up in here. I did decide to go ahead and put some braid on all these wires here. Left the ground wire loose because it doesn't really matter. So I'll go ahead and do the left turn signal now, get that covered up. All right, I'm going to leave this end loose here. I'm not going to wrap it in tape because I'm not entirely sure how these are all going to connect here. So I'll just leave those loose for now so that I don't have to unwrap it later. That gets me all the way down to the horns, which is, I think, far enough. So let's go ahead and tuck that thing in there. It was actually easier than I thought. I was able to just kind of push it through because it's so stiff, and I was able to just grab it here, pull it around. So you can see here, coming around, maybe you can see here. Everything's just laying loose in here, so I've got that in the side marker there, headlight, running lights, whatever. I don't have the clips that go here to hold the wire in place. I think this is how this is supposed to run, is under there. I pulled the horn through. So I've got to order those clips. They're in the assembly manual. Sorry, turned around the right way here. These guys. I don't even know what these are called, but I'll go dig those up, find those, so I can get all that. They show what do they have here? So they don't actually show what those are connected to, but theoretically that would be the core support. So I got one on each side of the center there. There's not really anything here that I see where those would go, unless it's these guys. Ought to be these guys here. Yeah, that probably makes more sense. And then I don't know if it'll fit with the way I have the loom on there and everything, so I may have to try and go with something like this, you know, like that, and just put a nut and a bolt on it. I can do that as well. But I'll try and see if I can get the factory type ones, and if those work, great. If not, that's my backup plan. And as I said, this only goes over to here. And I ran out of wire loom there, so I've got to finish that up. And then that just comes around the other side and keeps going. So that's about all I can do with that one for right now. I can start entertaining some of the other wiring here. So the horn relay is a bit tricky. Horn relay, what am I saying? Fan relay. Get this out of here. So we have this guy, 40 amp. I've got to split this into two because there's two fans. And then I have to deal with the trinary switch for this guy. So there's a lot of wiring that has to be done. I have to make some kind of diode arrangement to get the fan control from here and also from the vintage air, which is where the trinary switch comes in. It's a little different than the way most of these are set up. Most of them you have a negative control to turn the fans on. So like a temperature sensor or something, you just ground it and turn the fans on. This one, the fan signal coming out of the ECM is positive, and you can't just take the two positives and connect them together because it'll short out. So I'm thinking I'll run a little diode thingy here. Let me see if I can mock that up, if I have enough parts to mock that up. And then I need to measure how much current this guy takes to turn on, which is probably not very much. Just to flip the solenoid on there. And I need to have diodes big enough to support that current drain. Let me see what I have here for parts. Well, I couldn't find any normal diodes, but I have a plethora of light emitting diodes. No shortage of those. So here's a little circuit example here. I just hooked it up to a little 9-volt battery there. So the idea here is you have positive coming in across this top rail right here. Let me get my meter, I can show you. My meter has seen better days here. It got alcohol or something on it from the pandemic and turned the screen all funny, but whatever. So, let's see if I can grab something that's got, okay, so the bottom side of these LEDs here is ground. So this will be ground right here, and then this is positive up here. Battery's low, but 7.6 volts, whatever you can see there. And what we have here is just a couple resistors into these switches to not blow up the LEDs. So you can't put 9 volts straight into an LED without blowing it up. So if I press that, that one lights up. Press that, that one lights up, right? And the thing to note here is the current can't go from this switch to this switch. So this side of this switch is going to stay. Well, I'll show you what. Yeah, like I said, I don't have enough hands to do this. If I look across these two here, so right now there's nothing. If I press this, still nothing. That's fancy. Let's try that again. There you go. So now we got 2 volts across there. I don't know if you could see that. All right. If you come over here and look at this one and do the same thing, nothing. All right. So the idea of the diodes is it lets the electricity flow in one direction only, the current. So in this case, when I press this switch, it allows the current to flow between this path, so from ground up to the positive rail, but it won't allow it to go through this path. If we didn't have the diodes in here, as soon as I press this, then you'd have the 9 volts going all the way over to this point here. And if this is the trinary switch, I don't think it matters because it's just open, right? So if one side's open, it doesn't really matter. But on the ECU or ECM, on that fuse relay box, when the fans are off, it's probably ground. It could be floating, but it's probably ground. And so if that's ground, then when the vintage air tried to turn on the fans, you'd have ground on one side, 12 volts on the other, poof, right? This is kind of the thing I'm thinking of. So basically what we'd have is this point right here, this would be the signal going to the fan relay. And this leg here would be the ECM, this leg here would be from the trinary switch, and then the diodes in the middle, these would be the diodes instead of LEDs, would keep the current from moving back and forth between the two. That's what I'm thinking. I'll draw it out here real quick so you can see what I'm talking about, but I don't have the proper LEDs here to do this, or the proper diodes to do this. All right, I think I have this all drawn properly here. So our 2 main inputs here, we have the ECU, ECM, whatever, fuse relay box. So we've got a 12 volt signal coming out of that to turn the fans on. We have the vintage air unit, and on the dryer, this is the trinary switch right here. When the pressure gets too high in the cold air system there, this flips on, which turns on the compressor and also wants to turn on the fans. So this is a pressure switch. The trinary switch is just a switch. It doesn't care whether this is ground or positive or anything, it doesn't matter. So normally on a normal fan setup, you would have this grounded, and then when this thing closed, it would close the circuit and turn the fans on. Like I said, in my case, it's backwards because this is a positive high signal here instead of a negative control signal. So I would take one side of the trinary switch here and connect it straight to 12 volts fused. The other side to the ECU, and then here's where the diodes come in. So we have one diode on each side, and as we said, positive 12 volts can come in here, but it can't go back this way. So either one of these can turn on independently of each other, and it won't affect this. This then goes into the relay. So when you energize this with 12 volts, it closes the relay. Then the fans here, this is connected to a 40 amp. I have a fused connection on the fuse relay box over there, which is nice. An accessory, there's 2 accessory ports on there. It's 50 amps actually. And that's it. So if neither one of these, if this is not 12 volts and this is open, then this whole system is, this is either floating or is ground. I don't know which, but whatever. Either way, there's no power coming down through this path right here, so the fan relay is off. And then if either one of these or both turns on, then we get 12 volts coming in here. And if there's a voltage imbalance here for whatever reason, if this is 12 and this is 11 or something, the 12 volts isn't going to back up through this thing. So it's okay like that. So that's what I'm thinking. I found a diagram similar to this somewhere else, but they had 2 switches on either side. So they didn't need the diodes there because it was just open or closed. Or open, there wasn't an open close switch, it was just open, right? So when you close it, it would put ground or 12 volts on it. When it's open, it doesn't do anything. Anyway, so I think this is correct. So the next thing I'm going to do, I'm going to try and get a measurement of how much current this guy draws, and then that'll tell me what size these need to be, and hopefully this is not a lot of current where I need some big, massive, beefy diodes on here. Let me hook up something here to measure that. So I hooked up my charger here on the lowest 2 amp setting. It's working, but you can hear that it's vibrating, so it's pulsing, which is not great. But we're getting 27 milliamps. I think that's right. 27 milliamps. All right, so we have 27. Let's do it. 12 volts nominal times 0.027 is 324 milliwatts. Which is not too bad. So a half-watt diode would work, you know, with no margin of error, basically. Right? Remember, the voltage can get up to more like 14.4, 15 volts potentially, and I don't know if that's correct. So I'll look into it. Probably, I'll see what let's look real quick here. Yeah, I was gonna try and do a quick search to try and find the part on there, but I didn't have any luck on a quick search there, so I gotta do a little digging, probably try and get a 25 volt 2 watt, you know, something like that. Should be fine, and I don't think they're going to be very big, but we'll see. Unless after having gone through all of that, one of you guys or gals out there has a better idea of how to do this, then I'll go do that instead. But yeah, it's getting kind of cold out here. The weather's turning, got a storm coming in. It's getting cold, so I think I'm going to wrap it up here. I'll post this, see what you guys think about that, and let me know if you have any thoughts or suggestions. And if not, Happy New Year. Pick you up on the next one. All right, so I wasn't real comfortable with the results I got on the charger there, since it was oscillating. So I was thinking maybe that wasn't the right measurement. So I decided to come out here and check it on the battery, see what we get. So if I run this guy now, 167 millivolts. That's a lot more. Yeah. So I gotta rethink my math a little bit. Should be okay though. I think we'll be able to come up with something that'll work. Let's do the math, what that works out to. Get my phone to turn back on. Calculator. Alright, so now let's do, where are you? Out. I'll do that again. So 12 volts, what did I say, 160? 167. 2 watts. See that? Yeah, I need to be probably more like a 5 watt to be safe then. So we'll do more digging on that and see. I could always do a dual relay setup if I had to, where you use one relay to drive the other relay, or a MOSFET or something else, some kind of circuit to keep the diodes from getting too much current running through them. We'll see. We'll see what parts I can find, or somebody may tell me, hey, that's stupid, why don't you do it this way, and then that would be better. All right, I'm gonna wrap it up there again for real this time. So Happy New Year.